Hello. Now we're going to start chapter 1. So chapter 1 begins by explaining the difference between the simple compound method and the interest compound method. But before we go there, I want to start talking about timelines and how to interpret it. Because I want you, every time you do an exercise, to first visualize the cash flows and then apply the formulas. So typically, we draw a timeline where we have a time zero, and time zero is basically today. The beginning of a new day, a new week, a new month, a new year. Then time 1 represents the end. Let's say we're talking about days. Represent the end of the new day and the beginning of the second. So when we read time 1, we can both interpret it as the end of day 1 or beginning of day 2. Similarly, for the point references as point 2, point 2 is the end of the second day, beginning of the third, and so on. Time 0 always represents the beginning of the first day. Time 0 is the beginning of the first day. Now, of course, we can change day to years, right, to months, to whatever time unit we want to focus on. There is an attachment illustrating how to read timelines right below the video or right next to the video in your Canvas page where this video is posted. So let's talk about a situation where we invest, let's say, $1,000 today, and I'm talking about years. And the question is, if I invested at a certain interest rate, let's say 10% per year, how much money am I going to have after 2 years? So at this point in time, what is going to be the future value, right, of this present value? So P stands for present value. Future value, we use F. I stands for the interest rate. And since we are talking about notation, let's already define N. N is the number of time units. So we have the 4 main variables we're going to be working on. P for present value, F for future value, I for interest rate, N for the number of time units. In this case, the units are years. So to figure that out, since I said the interest rate was 10, we need to know how does interest accrue. So most basic method is what we call the simple compounding or simple interest method. Let's say simple interest method, because later we're going to use the word compounding for the other method. So let's keep it the least confusing possible. So the simple interest method, what it says is that it relates these variables as follows. The future value, it's equal to the present value, 1 plus the interest rate times the number of time periods. Okay? So if you put a certain amount in your investment and you're going to earn interest at a certain frequency, we are assuming everything to be in years, so this will be an annual interest rate, and the amount of interest you earn depends on the number of years you invest. Given this relationship, we can figure out how much money is there at the end of 2 years. Okay. Note that this is a linear way of compounding interest. So just plug in the numbers. So I said $1,000, 1 plus an interest rate of 10%. We always write the interest rate in decimal form. And the number of years in this example is 2 years of compounding. So as you can already figure that out, we're going to have $1,200 there. Okay. So to contrast, let's now talk about the compounding interest method. The compounding interest method states that the future value is equal to the present value 1 plus the interest rate to the power of n. So you can see that this is an exponential formula. Interest accumulates exponentially. In other words, here you're always earning interest in the simple interest method. You are always earning interest on the amount that you first invested. Whereas for the compounding interest method, you are earning interest on the amount that it is in the investment at the beginning of each compounding period. So let's just compute it first and then I'll say a couple of more words about it. So 1,000, 1 plus the interest rate to the power of 2. And this will give 1210. So here we have 1200, whereas if we compound interest according to the compounding interest method, we have 1210. So we just found out that for a situation where we have an investment of $1,000 at 10% per year over 2 years, if we were to accrue interest according to the simple interest method, we'll get 1200, because the simple interest method accrues interest in this fashion: 1 plus the interest rate times the number of years, whereas the compounding method will get 1210 as a future value because interest compounds in this fashion. So what's going on in the compounding method is that you earn interest on the amount of money that is there at the beginning of every period. Or in other words, so how much money do we have at the end of time 1? Let's say when n is equal to 1. Well, we have how much money we put the present value, 1 plus I to the power of 1. Right? And this means that at the end of 1 year we have $1,000, 1 plus the interest rate to the power of 1, $1,100. Well, when n is equal to 2, the future value is basically equal to how much money we had there in the previous period and this money is gonna earn interest again. So the amount we have there at the beginning of the second year, it's equal to 1 year of interest compounding on the top of the amount we invested, and then this amount earns interest 1, which is this stuff, plus more 10%. Note that this ends up being 1 plus I times 1 plus I, so 1 plus I squared, and that's how you get the 1210, which is basically equal to how much money you had there in the first period times 1 plus the interest rate. In the simple interest method, you always earn the same amount of interest per year. So per year, in this method, given these variables, per year the interest is fixed at $100, which is basically the 1,000 times the interest rate. So if the n was equal to 3 in the simple interest method, you'll get 1,300. If the n was equal to 4, you'll get 1,400, because it accrues in a linear fashion. The increments are always of the same amount. Right? 0.10 times 1, so 10%. If you keep it 2 years, 0.10 times 2, which means 20% more on the top of what was there. If it was n equal to 3, then 0.1 times 3, 0.3 plus 1, 1.3, meaning 30% more on the top of what you invested initially. In the compounding method, the amount of interest you earn is growing. In the first year, those two methods give the same result. Here you'll have 1,100 in the simple interest method after 1 year, and in the compounding interest method too, 100. The difference between the two methods happens after the first instance of compounding. As time goes by, the amount of future value, right, compared against time, right, the simple interest method is accruing interest always with increments of $100. Let's say year 1, so this will be 1,100. Right? But by year 2, this is 1,200, whereas if you are earning interest according to the compounding interest method, by year 2 it's 1,210. They are only the same at year 1, and then as time goes by, the difference starts getting larger. For example, if we were to keep for the compounding interest method, if n was equal to 3, right, then the future value would be equal to how much we invested, 1 plus the interest rate to the power of 3, and this would give 1331. So at year 3 we'll have $1,300 if we were to follow the simple interest method, whereas in the compounding interest method we would have 1331. This idea is illustrated on your textbook and explained in other words on page 3. Page 3. Simple interest method versus the compounding method. I also have an Excel spreadsheet in Canvas for you to play with, and you see graphically how this discrepancy gets really huge as time goes by. Not surprisingly, the financial system operates under the compounding interest method, not the simple interest method. And since we are here, let me also advise to read from page 6 up to page 8 about how to interpret timelines. That's where the textbook describes that. So we did an exercise where we found the value of f. But given that these formulas have 4 variables, f, p, I, and n, then there are 4 different types of questions that can be made. Let's focus on the compounding method. From now on, because this is the most frequently used method, and that's the one the course is going to be based upon. The simple interest method was just introduced to contrast the difference between the two methods. Most of your assignments and homeworks and exams are going to be about the compounding method. You only ask to solve questions with the simple interest method if that is clearly stated in the question. The question says, use the simple interest method. If the question does not say this phrase, then you are to use the compounding method. So the compounding method is the foundation of this course. Now, let's again focus on a timeline. Let's say that now we have 5 years. And we want to have, let's say, $20,000 in 5 years to buy a car. How much money do we need to invest now in order to achieve that goal if we were able to get a return of 10% per year? Right. So I'm trying to ask you, find P given this F, an interest rate of 10%, and an N equal to 5. In this case, the units for time are years. So that's the formula I showed you just a second ago. We need to solve it for P. And then plug the numbers. So how much do I have to invest now in order to have $20,000 in the future, given an interest rate of 10% and 5 years? And the answer is $12,418.43. But let's say I only have $10,000 now. If I only have $10,000, see, that's how much I have. How much would I have to earn as a return per year in order to achieve the same goal? So for that, if I only have $10,000 and I want to have 20,000, what is the interest rate that I need to earn per year, given that this is constrained to 5 years, in order to achieve this goal? And the answer is interest rate is equal to 0.1487, the same as to say 14.87%. So if I only have $10,000 and I want to turn them in 20,000 over a 5-year span, then I have to earn 14.87%. So we already solved the question for the present value, another for the future value. Now we did the one for the interest rate, and therefore the last variable that we can ask for is n. So let's go back to assuming that the interest rate is 10%. I only have $10,000 now. The investment that I want to, the financial security I want to invest in, imagine a certificate of deposit or something like that with a fixed annual return of 10%. Then if I have to have $20,000 in the future, how long will I have to wait? How long would it take me if I just have $10,000 to invest now, 10% return, but I still want to have the $20,000? So we can go back to this formula and plug the numbers. So 20,000, that's how much I want to have in the future. 10,000 is the present value, how much I have to invest now. Interest rate is 10%, and I'm looking for the n. Now I strongly suggest you use the solver in your machine, right? Or MATLAB or whatever software you have, rather than solving it algebraically. But if you, this is not a math class, but if you want to do it, be my guest. So here we have this kind of scenario, right? So basically this would be equal to 2 equal to 1.1 to the power of n. Then you could take the log and therefore find out that n will be equal to the log of 2 divided by the log of 1.1, and the answer would be 7.27 years. Now, how long is 7.27 years? This is how you would write the answer in the quizzes. But when you say this to a client, and if that client is not savvy with the finance world, then they'll probably want to at least have it this in months. Well, then you just break it into months, right? So we said that n would be equal to 7.27 years. So this is equal to, say, 7 years plus 27% of 12 months. That's how many months you have in a year. So that will be 7 years plus 3.24 months. And you can go into further detail. So far we realize this is 7 years plus 3 months plus 0.24% of how many days there are in a month. So this is 7 years, 3 months, and I'm gonna stop here. You can go to wherever you want in terms of the granular time unit. Let's put it like this: 7 years and 3 months and 7.2 days. So you could answer the client pretty much this level of detail. If you want to go to hours, you can also go to hours. So that will be 7 years, 3 months, and 7 days, and 0.2 of the 24 hours that are in a day. So 7 years and 3 months and 7 days and 4.8 hours. You can go to minutes, seconds, milliseconds. It's up to you. In our exercises, when you in quizzes and exams, when you asked for the answer, is in the time unit that the exercise was made. So we're talking about years, so this will be the answer: 7.27 years. In real life, you can break it down to whatever level of detail you want.